Hi, this is Dr. John Bergduff, and this is a video on the order of operations. The issue at hand here is, suppose you have a mathematical statement that has several different operations in it. Operations like addition, subtraction, multiplication, parentheses, exponents, all those sorts of things. If you have a lot of different operations in one statement, how do you decide which one to do first? Let me show you what the dilemma is. So here's an example that at first looks pretty simple, but you're going to get a different answer depending on which one of the operations, subtraction or multiplication, you do first. If you don't know that there's a rule, you might say, well, why don't I just do the operations from left to right? So I see 15 minus 4, and I say, okay, 15 minus 4 is 11. And then 11 is multiplied by 3, so 11 times 3 would be 33. And that's got to be correct, right? However, if instead of doing the subtraction first, you do the multiplication first, you would multiply the 4 and the 3, and you get 4 times 3 is 12, and then 15 minus 12 is 3, and that's a different answer. So it obviously makes a difference which operation you do first, and how do you know what's the right thing to do? So it turns out in mathematics that we have made an agreement about the order in which operations are done, and this agreement is right here, or stated simply at least. What it says is if a statement has parentheses in it, we should do that first. If there are any exponents in it, we should look at them next. If there are multiplications and divisions, we will do them next, but not that we do all the multiplications and then we do all the divisions. Multiplication and division are sort of at the same level of importance, and so if there's more than one of those, some mixture of multiplication and division, we do our multiplications and divisions from left to right. The last operations we do are addition and subtraction. They're also at the same level, and we do them from left to right. Now, the order of operations agreement is not too hard to remember, but it's still very common for people to come up with sort of a memory device or two to help us remember what the order is. So one thing that is sometimes done is simply just to take the first letters in the order of operations agreement and write them down. And if you do that, you get the word, or sort of word, PEMDAS. Parentheses, exponents, multiplication and division, addition and subtraction. And that's a wonderful little word to help you remember the order of operations. Lots of people use this. I happen to prefer a different memory device because it's a little bit more colorful and a little bit more fun. And here's what that is. The memory device I like is called Please Excuse My Dear Aunt Sally. Now, where does this come from? Every family has an Aunt Sally. Kind of the crazy lady. We sort of keep her in the basement most of the year because she bothers people. But on Thanksgiving, we bring her up for Thanksgiving dinner, and she kind of makes a fool of herself. She drinks too much. She gets up. She dances on the table. She knocks over a lamp. She steps on the cat's tail. She makes fun of your girlfriend. All these terrible things. And so at the end of the night, you have to tell your girlfriend, please excuse my dear Aunt Sally. Now, the letters in Please Excuse My Dear Aunt Sally obviously represent the same things as in the order of operations agreement we looked at on the previous slide. The P stands for parentheses. If there are any parentheses in the statement, we simplify what is inside the parentheses first. The E stands for exponents. So if there are any exponents, we will simplify those, and they may be within the parentheses, but we look at the parentheses first and then the exponents. My is multiplication. D is division. And again, we remember those are basically at the same level. We handle them from left to right. And finally, AND is for addition, and S is for subtraction. And those also are at the same level. We do them from left to right. So let's go back to the example that we had a minute ago, and now we know what the correct response is. This statement has a subtraction and a multiplication. Not every mathematical statement will have all the different operations. There's no exponents, there's no parentheses, for example. But we look at the operations that are there and we find them in the statement, please excuse my dear Aunt Sally. And as we read from left to right, the first operation we come across is the M for multiplication, which means we do the multiplication first. So the first thing we would do in the order of operations is we would say 4 times 3 is 12. The subtraction comes later, so we will do the subtraction after the multiplication, and this tells us that indeed the correct answer from the previous slide, we need to choose the 3. Let's look at a couple more elaborate examples and see how the order of operations agreement would apply there. This one's a little bit harder, and as you see, there is a parentheses. So the order of operations says that the first thing we need to do is focus on what is inside the parentheses and work on that first. Inside the parentheses, I see a division and a multiplication. If you forget that multiplication and division are at the same level, you might think that you do the multiplication first and then you do the division. But remember that multiplication and division are done from left to right. And being at the same level, this division comes first, and so we'll do the division first. We'll ask ourselves first, what is 8 divided by 2? And 8 divided by 2 is 4. Then we can do the multiplication. 4 times 3 is 12. Once we've completed everything in the parentheses, we no longer really have to write those parentheses. We can just say 12. So we took care of the parentheses. I do see an exponent, so the order of operations tells us to pay attention to that exponent next. 4 squared is 16. And there's only one operation left, so there really is no confusion, but it is a subtraction. That's at the end of the statement, please excuse my dear Aunt Sally. The final answer is 4. I hope that's helpful. A couple more just to build a little bit farther. This example is interesting because I have layers of parentheses. They're in different shapes so that I can tell them apart. But notice that I have some round parentheses that are inside some square parentheses. When there are layers of parentheses, you work your way from the inside out. In this case, the round parentheses are on the inside. I would look at that first. So if I do that, what would happen is I'd leave everything else alone. I'd leave the square parentheses, I'd leave the 12 in the division. I would do the subtraction inside that parentheses. 3 minus 1 is 2. And so I would content myself with just doing that much. While I'm at it, because I haven't written anything for the second parentheses yet, I might as well go ahead and say, well, look, there's parentheses over here too. 2 plus 1 is 3. Let's go ahead and do that. Now I still have parentheses. They're the square ones. The order of operations says stay in those parentheses, simplify until the parentheses are gone. Within the parentheses, I see an exponent, so I need to take care of the exponent next. 2 squared is 4, so I'm going to say 12 divided by 4 divided by 3. Still I have parentheses, so working inside the parentheses, 12 divided by 4 is 3. And since the parentheses have been completely simplified, I don't need to write them anymore. And the only operation remaining is that final division, and 3 divided by 3 is 1. So the answer, the simplification of that expression gets me to 1. One more example. This one has a fraction bar in it. A fraction bar, in a sense, serves like a parentheses. It basically says that everything in the numerator is a group that can be thought of as being inside parentheses. You don't have to write the parentheses, but I'm just illustrating here. And everything in the denominator is also grouped together like that's in parentheses too. So as I simplify this, I will work inside the parentheses. I have 2 parentheses. I can work on them. They have to stay separate, but I can work on them kind of side by side. In the parentheses on the top, the first operation in the order of operations would be the multiplication. 3 times 2 is 6. So the numerator will become 5 plus 6. There's a little bit more going on in the denominator. I have an exponent inside those parentheses. That's what has to be done first. 4 squared is 16. So there we go with that. The numerator, there's nothing left but an addition. See, I'm going to bounce back and forth between the numerator and the denominator. They're separate, so I might as well. 5 plus 6 is 11. That completely simplifies the numerator, so I don't need to write the parentheses anymore. I've got to kind of catch up in the denominator. 3 times 2, there is an operation of multiplication, which will happen before the addition. 3 times 2 is 6. I still have parentheses, 6 plus 16. I think I'll make another column and continue over here. The 11 in the numerator is just sitting around now. In the denominator, 6 plus 16 is 22. And the fraction bar represents a division. 11 divided by 22 is not a whole number, but if you think about simplifying fractions, you can notice that the 11 is 11 times 1, and the 22 is 11 times 2. So there's a common factor in the numerator and the denominator, and the part of the division that does make sense is that 11 divided by 11 is 1. So the 11s, we usually say, divide out. And what we would be left with is 1/2, and that would be simplifying that expression as far as it will go. So I hope these examples illustrate the order of operations. Please excuse my dear Aunt Sally. Don't forget Aunt Sally, she'll be back for Christmas. And remember, parentheses, exponents, multiplication and division from left to right, addition and subtraction from left to right. Bye, Sally.